3D printing technology has rapidly gone from something that was challenging, that was expensive, into something that's really possible for consumer to use very easily without a lot of costs or capital required. 3D printing can be used in the foundry industry in a lot of different ways. Probably the most popular that you would think of right away is rapid prototype development. If a customer wants to make a change, we can quickly model that, print it out, and see if it will fit and work on the tooling, and even run a quick sample.
So 3D printing has a couple uses in the foundry. The first thing is for rapid prototyping and also for making one-off parts. It can be very costly to build a pattern and to build core boxes. So if you have a one-off part that you're only making one of, printed cores and printed molds are a very excellent option because it means you don't have to sink a bunch of money into a pattern and a bunch of money into the core boxes.
Another way that you can use 3D printing in the foundry is helping to eliminate some tooling costs for one-off or small run castings. It can also be used in a way that you might not think, and that's in creating complex cores. So things that would be complicated to make using traditional molding methods, something that you might have to make into multiple core boxes, could possibly be converted into a 3D printed core, which eliminates the cost and time, and as well as the challenge that comes with assembling cores. The big benefits are helping to reduce lead times and giving you the opportunity to test things out quickly, to hold tight tolerances that more and more customers are requiring, and gives you the opportunity to make geometries that haven't been possible before.
3D printing is really great because when it comes to, especially for molds and cores, when it comes to molds and cores, if you want to make a mold, if you want to make a core, you need a pattern, you need a core box, right? Well, if I want to make one part, then there's no reason for me to make a pattern and a core box for one part if I can just 3D print the entire core and the entire mold, depending on the situation. So one part in particular we're using a printed core for right now. We're running only a small quantity of those parts, and it's also a core that would be very, very difficult, if not borderline impossible, to make in a no-bake core box. It's a two-piece printed core, but if we were to try to make that in a no-bake core box, it would be probably 7 to 8 individual pieces of this core, all assembled together. The more core assembly you have, the more risk you have, the more time it takes, and that all becomes difficult, and the quality of that 3D printed core is just much better than what we can produce here.
Consistency. Do you want your assembled core to be the same dimensions every time? 3D printing can give you the same dimension every time, but if you're trying to glue it together or fit them together and you have mating surfaces, then you introduce even more variation every time. So it helps eliminate that. At RMG, the foundry in Anniston, Alabama, they're using 3D printing to create tags on their parts. And so when they have a date tag or they have a custom tag they need to make, they can just make a tag very quickly and put it on the pattern. You don't have to wait or get it sent out or order it ahead of time. So if something breaks or you lose it, you can replace it really quickly.
We can use 3D printing in other areas in the foundry well beyond just molds and cores. One application that I think becomes very interesting is potentially using 3D printed models to train our molders. This is something that I know has been explored by other people in the industry, and it's something that we've been talking about internally. Being able to print or 3D print a plastic model of a complex core assembly and being able to see how everything goes together before you ever make the core box. That way we don't sink a bunch of money into a core box not knowing if the core assembly is really going to work, or multiple core boxes for that matter. Same thing goes for the mold, right? If we build a mold and a core assembly that doesn't work for our people on the floor, we'll be able to see that and play around with that with a printed model before we ever invest the ridiculous amount of money that you might have to invest in a pattern or the core boxes.
At the last Casting Congress, there was a really interesting company there that was 3D printing ceramic molds. And they were small molds, but they were basically creating these small ceramic molds and then taking basically a puck of a material, mostly low temperature materials like aluminum, and then putting it into essentially a microwave oven, and the material would melt and then create a small prototype casting. And so that's the kind of ways that we're using 3D printing to make castings that you might not think of. And I'm sure that there's more technology that we're going to see in the next several years.
I think it would be really cool to be able to have our own 3D printer, to be able to 3D print internally for molds and cores. I think that would be really nice. It would also be nice to have a little one just to make little plastic parts for prototyping and experimentation and training purposes, and I mean even maintenance parts that are low strength and can be made out of that plastic film. I mean, that would be something we could use a 3D printer for. So it would be nice to have some type of a small 3D printing capability.
Lawton Standard is continuing to use new technologies, and I think that we're going to see more 3D printing being used both in complex cores for our customers, but in quick tooling adjustments. I think that we really participate in these new technologies. We have a lot of folks in the engineering team who are really excited and want to help develop this technology. So I think we'll continue to see it throughout our foundries, and whether that's working with industry partners or having our own capital to print our own mold components, or who knows, maybe even cores in the future.